This is going to be the introduction to the chain rule. So here we have some fractions. We've got a over b times b over c. Now with these, it's a bit like the b's are going to cancel and we'd be left with a over c. We're going to use the same idea but with some differentials around. So the chain rule looks like this. You're used to dy dx. Well, what we could do is we could write it as dy d something times by d something dx. It's the same idea as up here. If the two somethings were the same, then they'd cancel out and you'd just be left with the dy over dx. We're going to pick a different variable other than y and x, and the usual one we use is u. So we're going to write it as du du. It's true whichever variable we put in there. This isn't a constant, it's a variable, so u will be a function of x. Now this is the chain rule and we're going to use it. I'm going to make another video which proves this, because this is very hand wavy at the moment, but the proof is off syllabus. Right, so here's how we're going to use it. Here's something that you could differentiate using first year techniques. The way you would do it is we could expand this out using binomial expansion. It would be long, but you know how to do it. And once you'd expanded it out, you get some sort of quartic, so something to the power 4, which you could differentiate each of the terms. We're going to try and do it quicker using the chain rule by picking some substitution that we can do. We're going to pick u to equal something to try and simplify it. General tactic here is we're going to pick u to be whatever's in the brackets. So, as an aside, we're going to pick u equals 2x plus 3. It's just the thing in there. Now u here, again, it's not a constant, it's a function of x. By picking u to be that, we can write y in terms of u. So we'd have y equals u to the power 4. It's just the thing inside the brackets to the power 4. So we've got y in terms of u, and we've got u in terms of x. With each of these, we could differentiate them. So for instance, on this one, dy du equals, well, times things down by the 4, by the power, 4u to the power of 3. And over here, we could work out du dx. So du dx equals, well, we're differentiating with respect to x, that goes to 2, and the 3 is just a constant, so it doesn't get to anything. Right, we've got both of those bits. If we look back at the chain rule, which was this one here, dy dx, the thing we want, is dy du times by du dx. Well, those are the two things we have. Dy du we have on the left, du dx we have on the right. So if we times them together, we get the thing that we're after. So, at the bottom here, dy dx, the thing that we're always after, is that thing times this thing. So it's 4u to the power of 3 times by 2. Now that's in terms of u. U is just this thing that we made up back in the question. We could substitute back in for this thing over here. Also, we've got a 4 times a 2, which we could simplify. So, putting it all together, let's do it on this one. We've got dy dx is 8 from the 4 times the 2 times u to the power of 3. Well, u is this thing up here, 2x plus 3, all to the power 3. We're done. So instead of expanding it out and differentiating each term by term, we've kept it as a whole in terms of the brackets. I'm going to do a second more complicated example now. So, okay, here it is, y equals square root of 1 minus 4x. Now at the moment you couldn't even expand this out. Later on in this year you're going to work out how to expand out binomial expansions like this. But we're going to make a substitution. Again, we're going to pick the thing inside to be u. So I'm going to pick u equals 1 minus 4x. So this thing here is y equals square root of u. Well, from first year stuff, we know how to write that in terms of something we can differentiate. This thing here is u to the power of a half. That's in a nicer form to differentiate. Differentiating both the bits, this one here, dy du, is timesing down by the power, we get a half u to the minus a half. This one over here, du dx is minus 4. So putting it together, dy dx, which if we just write out the chain rule again, is dy du times by du dx. Timesing those two things together, well, we've got minus 4 times a half, which is minus 2, times u to the power of minus a half. Well, that's not particularly neat. So let's write it back in terms of x. dy dx equals minus 2, or u to the power of minus a half, that's 1 over square root of u. But that's still in terms of u. So it's minus 2 over square root of, and back up here we have what u equaled, it's 1 minus 4x. Done. Right, I'm going to give you one to have a go at. Similar sort of style. Have a go at this one. Y equals minus 3x plus 2 to the power of 3. Pick a correct value of u, you want the thing inside the bracket, and you might want to pause the video at this point. Right, okay, so quickly going through it, I'm going to pick u equals minus 3x plus 2, and so y equaled u to the power of 3. Differentiating both the bits, dy du is 3u squared, du dx is minus 3. Popping those two bits together, we get dy dx is these two things times together, which is minus 9u squared, but that's still in terms of u, so putting it back in terms of x, it would be minus 9, and then in brackets, minus 3x plus 2, running out of space, to the power of 2. So a bit messy at the end.